charges for the main group elements so that you can determine the charges for transition metals there. An example here, when we went through these, and oxygen is group 6A. So if you look at the a couple of slides in your textbook as well as on the PowerPoint there, if you look at the main group elements there, oxygen group 6A. So oxygen oxide will bear 2 negative charge. And the key that you need to pay attention to is that when you write out a formula for a compound, the formula has to have no net charge. Okay, the key word is net. So 2 oxygen titanium dioxide there, 2 oxygen, that's 2 times -2. That's -4. Total negative charge is -4. So titanium has to have +4 in order to make it 0, no net charge. So titanium, the charge on titanium in TiO2 would be +4. And niobium oxide, oxygen is -2. -2 times 3, -6. So you have 2 niobium there, so 2 times 3, and that's how you determine the charge on the MB there is +3, no net charge. That's the key you need to remember there. And then for the sodium dichromate, we did this. Well, if you don't know the charges for a particular element there, you can always assume it's X, and then you set up the equation so you add all the charges from all species together, and that should result in 0. Now we are not going to ask you if you have 2 unknowns there, you can't solve that kind of problem using one equation there. So for sodium dichromate, sodium is group 1A, so that's something that I expect you to that M word memorize. So sodium is group 1A, positive 1. Okay. Oxygen is group 6A, -2. So 7 times -2 is -14. 1 +1 times 2 is +2. So -14 +2, that's -12. Now when you have -12, chromium, each chromium has to contribute so much, so that 2 chromium will give you a total of +12 charge. So 2x equals to +12, x equals to +6. So that's how we determine the charges on different ions there. A certain amount of information you have to memorize, and there's no other way around. Okay, so you have to know these, memorize the charges there. Okay, and then for naming the compound, the next when I give you the slide on the previous slide there, when I give you the formula there, I always call them by the name there. Now, how do we name the compound? There are certain rules. Now, those rules are really, there's not much flexibility there, and you just have to memorize the basic rules for the nomenclature. And for naming ionic compound there, you name the positive ion or cation with the name of the metal plus the word cation. So if you have sodium plus, and that's the sodium cation. Now that's the requirement there, but every once in a while you see in chemical literature, and then you see the term sodium ion without the word cation there. That sodium is a metal. Metal forms positively charged ion. So sometimes the word cation or cation is not included there, and then rather we're using the just the name of the metal plus the word ion. Okay, so that's how you name the positively charged ion. For transition metal, well, metal is going to be positively charged. So for transition metal, we use the name of the element with the parenthesis and a Roman number in that parenthesis. Now that Roman number indicates the number of charges on the transition metal elements there. So using cobalt as an example, this particular ion, we would call it cobalt 2 cation. And this cobalt ion, we call it cobalt 3. 2 and 3 indicates the positive charge, positive charges there. Okay, so for transition metal elements there, whenever you name them, and for the ions there, whenever you name them, you have to indicate how many charges they bear. Because transition metal elements, they bear different number of charges depending on who they're with. So cobalt could have 2 positive charges, could also have 3 positive charges. Without putting that Roman number in the parentheses there, you can't really determine what's going to be the formula for, say, cobalt chloride and cobalt or cobalt oxide, and for things like that. Then you know the charges for the monatomic ions for non-metal elements, the main group non-metal elements there. However, if you do not put that Roman number in, you will not be able to determine what is the charge on the metal elements there. So for transition metal, that number in the parentheses is very important. This number indicates the charges there. Okay, the positive charge on the metal ion there. And again, naming the ionic compound for the anion part, and we take the stem of the name for the non-metal element. So chlorine, well, that we add IDE to the stem of the name there. So chlorine, the element, we name it chlorine, fluorine, we call them fluoride, chloride. Okay, so you put the oxygen, oxide. Okay, so you add IDE to the stem of the name there. And again, you say chloride ion, oxide ion. So this is the base. If you have the name for the cation and the anion there, and when you name the ion compound, you simply put those two words together. So sodium chloride, and that's how we name table salt, sodium chloride. Cobalt 2 oxide, well, and that cobalt oxide there, and the oxygen has 2 negative charges there, cobalt 2, and that's the positive charge on cobalt ion there. So in chapter 3, there actually, if you read the textbook there, in chapter 3, we actually have a whole list of different rules that you need to follow. And I won't spend, when we get into chapter 3 there, I won't spend a whole lot of time in talking about those, the details about those rules there. Rather, I want you to take the time when you read the textbook there, pay attention to those rules there. Now, the thing here is that this is, for many of you, this is probably the first time that you are being exposed to naming the inorganic compounds there. And so many of you are taking the chemistry class for the first time there. So I will not require you, or at least I will not test you for the first 3 in-home exams. I will not test you on the nomenclature. Okay. If I give you the name of a compound in an exam, I will also put the formula followed by that name there. If I give you the formula, I will give you the name, and that's something of less of a concern, because if I have a formula there, you already know how to write that chemistry word. And if I just give you the name, you may not be able to come up with the correct formula. So I will make sure that in exam questions there, if I use the name of a compound, I will also give you the formula of the compound. So, however, I do expect you to know the nomenclature for inorganic compounds there. So pay attention when we finish this particular topic in chapter 2, when we get to chapter 3. Make sure that's an information that you need to work on. And when you take the final exam, sometimes the questions in the final exam, because we don't get to make up the questions for the American Chemical Society standardized exam. So sometimes they will ask you a question with just the name of the formula, name of the compound. You have to know their formula, and you have to know the nomenclature in order to come up with the formula. So you have about 3.5 weeks to work on the nomenclature there. For the first 3 in-class exams, you will be given both name and formula, but on the final exam there, you may be tested on the nomenclature part of the inorganic compounds there. So these are the things that we need you to remember there. Once again, the name of the polyatomic ion, that's very important. If you look at the textbook in chapter 2, chapter 3, there are multiple tables where we have polyatomic ions listed in there. For this particular course, we need you to memorize at least those 16 polyatomic ions there. We showed you the table